Hey guys, we got our next installment here where we're going to be doing some some batch hacking, and that is going to get us a lot more money at a quicker pace, so that way we can stop waiting and doing things. So I've never done this. I'm going to try my attempt at this. And first off, I grabbed a whole bunch of other code that we've used in other places and things I've added a little bit too. But that's not going to matter a whole lot because we'll have to morph what it is that we've had before and kind of go from there. So first, we should probably talk about what is a batch hacking algorithm and how we're going to incorporate that so we can actually understand what that means. So I'm going to go and switch over to my browser here. And here we go. Should still be able to hear me. All right, so this should be fairly quick. And I grabbed the wrong one. Here we go. So I put this link in the description, and it talks about the various different algorithms that you can use. And the nice thing about this is that it's an algorithm. It doesn't tell you the actual code, so you still have to code it up, which is good for experience and understanding. And if you end up going in this line of work, that's a lot of what's going to happen is you're going to get algorithms, which are kind of the high level, what it is that you're trying to do. And then you need to be able to break it down into the various pieces. So what it is that we're trying to do, something very similar to this, where we've got some weekend grows and hacks going, but you're trying to get them in such a way that you reduce the amount of time that you're waiting. So for instance, in the normal, quote unquote, normal way that we've been doing it is that we would weaken it all the way down to where you're at 0. Then you would grow, up. When you grow, that increases security. So then you would run weaken, get it back down, and eventually you keep repeating those 2 steps until you get everything up to 100. Well, what the problem is if you're weaken, which is, the longest piece here, if this takes 5 minutes and then a grow takes, we'll say, a minute, if you do them one at a time, you end up with 5 minutes plus 6 minutes, or 1 minute to make 6 minutes. Then you got to do it again. So another 5, so 11 minutes, and then you can do your hack. And so we'll just say, you're a little over 11 minutes. But if you can start them all in one go and have them finish at different times, you can shorten that. So now what would have been, 11 minutes, now we've got this long piece here, which is 5 minutes. Plus this little extra here. So now we're looking at potentially a little less than 6 minutes to be able to go through, which is almost half the amount of time to be able to get the same amount of money. So at half the time, that's great. And then you can get really crazy. And instead of doing batch 1, letting everything finish, and then going to batch, doing it again, you can then also schedule repeating pieces, so that way you can see these are slices, and this particular slice would have been lined up perfectly on this piece. So the idea is that you can then really stack these really deep to where you're constantly basically getting to hack every minute or 30 seconds, or you're constantly just hacking at that point if you can get all these batches and everything correct. So instead of every 15 minutes getting 1 round of hacking, you could potentially doing it every 10 seconds, which is quite amazing. To do that, you have to be able to manage your RAM and a lot of starts and stopping times to be able to fit all these in. And then you have to come up with what percentage of hacking you want to do to be able to get this. So there's a lot of math and working with threads and the available RAM that you have. And so it's a lot more complicated. And one of the things that is worth knowing when doing this is the mechanic of the security level. And so it kind of talks a little bit about that here. But the general gist of it is that things run at the quickest amount of time when your security is the lowest that it can be on the server. So you want to be able to run these when security is at 0, which, you know, we all knew that. But the thing that's important is that the time it takes for it to run is based on when you start that operation. So it doesn't matter what the security is when it ends. What matters is where the security is at the beginning of it. So that's why you can say in this batch 1, start this, and this will have the same time as this weekend because they're both 0. And this will be at its fastest because the security is at 0, even though when it ends here, it's no longer, you know, the security's changed, but because it started at 0, that's what goes. So that's what matters. That's a special case with this. That's some of the reasons why you can get away with a lot of this. So that's kind of the special piece. So we'll go on back and switch over. And now we're going to attempt to do that. So there are 2 pieces. And the one thing I did fail to mention in this is that I'm going to attempt to write this using the base game bitnode, the base starting, like if you were to start the game at the very beginning, I'm going to start it as though you're using that. So I'm not going to be using a lot of the other special pieces, mechanics of that's part of your, you know, ascensions or any of that other piece. You know, I have this int, which is different. You can just ignore that. That doesn't affect anything that's happening that we're going to be doing. So I forgot to mention that earlier. So basically what we need to do is figuring out the various different pieces of what we have. So first things first is we need to pick a target that we want to hack, right? So that's got to be something that we do. Right now, we're going to stick to just one and not attempt to do this to multiple servers. And the reason for that is it becomes much harder because you have to manage not only your RAM, but you have to share that RAM with 2 different pieces. And so you're going to have some competing with the batches. And so we're just going to, for simplicity, start and only do 1. And that will get us at least out the door. And if you guys feel like you want to tackle that, that's fine. But the big thing is you got to have enough RAM and be able to run all these things. Because we're going to be learning a lot of scripts to be able to get all these timings, right? So we got to pick a target. We need to figure out how much free RAM we have, right? And then we need to we need to calculate the number of threads for hack, weaken, and grow based on the free RAM, right? So if I have 10 gigs, I'm not going to be able to get probably 70% of, you know, the money, depending on what server I'm hacking, because it's going to require too many hacks, weakens, and grows. So we need to select a specific percentage that we want, you know, based on what we were doing before, right? So if we kind of just look at what it is that we had, right? We have, right, we had our thing that says, hey, how many weakened threads based on what our security is and what it takes to get to minimum, right? Security difference, right? So that tells us how many threads we were needing. right? So that changes depending on how many hack threads that we use. It changes depending on how many grow threads we use. So we got to calculate all that ahead of time, so we make sure that we have enough free RAM. And depending on how we go, right, this is enough for batch 1. And I think what I'm going to do is, just to get things under my belt, I'm just going to set this up to where I just do batch 1, let it finish, and then do batch 1 again, and let that finish, and then do batch 1 again. It's not as fast as we could be going, but it makes the calculations and everything, I think, a lot easier, and will be easier to program. Once we have something that's running, working, then we can go and modify that to try and do like batch 1, batch 2. Because not only do you have to calculate based on free RAM, you would then have to, if you're going to do 2 batches, for example, you would need to divide this in half, this free RAM, so that way you can be able to do between the 2. And I don't know how that's going to work out. So first, we'll just do it with 1 batch. Then we can kind of figure out from there, right? So that's kind of the thought process. All right, we need figure out what's else here. All right, I'm going to go look at the doc real quick. And what do we got? So we've got the weekends. I think, because, you know, it mentions here that there's kind of different batches. There's like a hack grow weekend. There's a hack weekend grow weekend, you know, so there's kind of different ones. So I'm just going to go with the simpler hack grow weekend, right? So hack grow and weekend, you know, as opposed to the hack weekend grow weekend, right? All right, so gonna go that route. All right. So we're gonna calculate number of threads for hack and for weekend and for the RAM. Now I think there was, let's go look at it at exec. Start another script on any server. I need to look at the run options, because I hear, let's see if I can remember how to do this. Var run blah, just to show you it doesn't really matter. No, there is type is run options. No, that wasn't it. I did it in another script somewhere. It was my test script that I was doing it in. It's gonna bug me now. BitBurner. All right, so what I'm doing is just did a Google search. I can probably change. Let me change. Come back. Chrome. Just did a Google search for the run option BitBurner, right? Grab the first one here. We've got the different properties: prevent duplicates, should fail, temporary, exclude from saves, number of threads it'll run with. Okay, so it doesn't have anything to like delay a thing. I was so certain that there was a way to like delay it a little bit. I'm not seeing it in here. All right, so let's go back. And just come back in here to the exec. Threader options, right? So exec, I think maybe run. No, but I think run is our own server, so that's run options. Yeah, I thought there was. Okay. So what we need then is to get that delay, we're going to have to change our hack script, right? To make it wait a certain amount of time before it then starts, right? So because we've got the different pieces, we need to be able to start those. So I need to start, right? So start 1, 2, 3, 4, 5, 7, 8, 9, 10, right? And then the grow would be more like here. Stop there. And then the hack will actually be more like, right? Because the hack is the fastest. You're not supposed to do that. Space here, right? So this will be more like this, right? So I gotta start this one. I need to delay a certain amount of time before I start this one and do this one. So I need to, calculate the delay before starting hack. Grow, and then we can right. So we gotta do those. So we got our threads, we got our delay. We need to change our scripts to handle that delay because we can't. I mean, we could do the delay in here. We'll try that first. Yeah. The problem with doing the delay here inside this particular program means that you absolutely can only do one batch, right? Because you're going to be stuck waiting for these before you can actually move on to the next batch, right? And so if we move the waiting to be inside of this in the individual scripts themselves, that will allow for that multi-batching aspect of it. It's just thinking about it here. So yeah, we'll do it that way, and then we can change and modify those the other ones. Okay, so pick our target, figure out how much free RAM, calculate the threads, calculate the delay. We need to run the weekend on target, weekend for target. Then we need to wait until we need to start the grow. Run the grow for the target. Then we need to wait until we need to start the hack. Then we need to run the hack. Wait for all three to finish. and then go back to the top. And we'll just say start next batch. Yeah. So that's going to be our deal. So we're going to pick, calculate how much free RAM we have. Then we need to figure out how many threads based on the free space. Calculate the delay between each of those. Then we go ahead and start running. Wait until we need to run the grow. Or wait to go there. And then we wait for all three to finish. And then we start back at the top. Evaluate, see if we need to pick a new target. And go from there. So before that, we need to actually be pick target. We need to have our security at the minimum. So at the security of the target to min. Right, you got to start at min first before you can do that. Because otherwise it's pointless. This is very high level. This does not go into how do you pick a target? Should you pick a target based on how much free RAM you have, etc., etc. There's a lot of little tiny details, but this is a high level algorithm to do this, and it'll get us going faster. So now we need to go. So here, let's go ahead and create a function here, and we're going to say pick target to hack. And to start off, we're just going to go cheap, right? We're just going to say food and stuff. So run monitor. You can see this in the monitor video. So we're going to target something that's a little easy at the beginning, so we can just get it working, right? So these are all pretty well comparable-ish. This requires one, so let's just do food and stuff for now, right? Script editor, pick target, we're going to return food and stuff, right? The other thing that we can do is we could pass it in as an argument, and at least that way we can go. So args, oh boy, it's been a little bit since I've had to use the arg. Script arg, it's an array. Go away. All right, it's an array. Length to get how many, right? So we'll say if the args.length is equal to 0, so you didn't put any args, that's when we're going to return our food and stuff. Otherwise, let's just assume that the first one is our server that we want, right? So return ns.args 0. So we'll say the first one is going to be the server. To do, add some error handling, right? So handle if not a real server, then use default food and stuff, right? Log error when not real server, right? So that way we can make sure later when we go and use this, etc., right? So we've got our pick target and target. Cool. Right. So next we need to get our thing down to security. So let's come down here and let's just create another function. And we'll say get target to min security. Right, so let's format. All right, current minimum. All right, so if our security is greater than the minimum, there we go. Getting target. Target name to min security before batch. Right, so we need to run the weekend scripts, which again has the securities and gets threats needed, which just uses and keeps going. All right, so let's come up and say get target. Let's at least put this in here. And this target. Come back here. And we want not just to run the weekend, we need returns the sleep time. So run, yes, I want to go, I want back up here. There we go. So we don't want to return, we want, that was the, is that seconds? Don't remember. Where'd she go? There it is. Get weekend time. Time in milliseconds. Okay, so I can just await this directly. All right, so what we're going to do is run the weekend scripts, and then we have var time to sleep equals that. We will await and sleep. Get this guy in here, and if we're going to be awaiting, we need to make this an async method. So await sleep time to sleep. And let's change this if to a while. So now it'll keep looping as long as for batch, we'll just put period there. So while the security is not at the minimum, we're going to sleep, do the weekend sleep If it's still not, it'll do it again. If it's still not, do it again. Finally, when it's out, we get our target to minimum security. This is now async. So we need to await that. All right. Now we need to get how much free RAM that we have. So we need to get all, so I haven't actually done code yet to just get all servers that are available. Right now I've just been using the purchased ones, right? So what I need is to actually get all servers. I'll just use the purchased ones for now. So script RAM, it's calculating it. Fine, we'll just keep calculating it then. All right, so now I lost where it was. Oh, RAMs, get free RAM, get script, there it is. Needs you. All right. So we need to get our free RAM. So function get total usable free RAM. Do I need a target? I don't think I need the target. All right, so what I need is, I have these, right? So what is the RAM usage on this? 0.1, that's fine. All right, so what we're going to do is I'm going to simplify how much RAM that I need. So each of the scripts could potentially have different varying uses of RAM, right? So I'd have to go look, but I think one of them was just a smidge bigger than the other one, right? So what I'm going to use is I'm going to get the value of whichever one is the largest one. I'm going to use that to figure out what my usable free RAM is, right? Because if I do my calculations are going to change based on how many hacks versus how many weekends. And since I haven't calculated how I'm going to be doing that yet, I need to be able to make some assumptions. And so the best way to do that was to just get whatever the largest one is of all those, right? So that's what we're going to do. All right, so let me get that over. I need that max script RAM equals, I need each one of these, right? So it's that one. This returns the number, right? So if, let's see, I believe actually there's a math dot max, I think. Max, yeah. That takes an array of values, so I can say, we'll just do this. Right, so this is that. So we'll say we have hack, we can grow. So now, whichever one of those is max, that's what's going to come in here, right? So then, where is run scripts to get free RAM of a particular server? So I will use that here. I have this lookup here. Let's cancel that. Reserved RAM. I have just this object which has home, gang, scripts, right? So these were just some these are purchased servers that I have, and I'm basically saying I don't want to use the first 32 gigs of RAM on the home machine because I want to reserve that for other scripts that I want to run. Same thing for my gang, for when I run my gang scripts and that kind of stuff. So that's an addition that I have added that is not in my other videos. So that's just used down here where I just get the host name if it is undefined. So if I try to look up into that object up above and it does not exist, such as, you know, food and stuff, then it will say that this is true. So this is called a ternary statement. This becomes what you get when it's true. So since it doesn't exist, it returns 0. So there's nothing reserved. If it finds it, such as host or home, then it will go and get what that value is. In this case up here, it was 32. 32 becomes that, and then we subtract 32 from what the max RAM is, right? So that's kind of what that piece is there. So chances are, I command click, this is my free RAM for that particular server. And then we were subtracting threads and moving on. So I'm going to still use this. Yeah, I still need this. Sorry, I had to yawn. Because I'm going to end up with 10 RAM spread between 2 machines. I still need to spread this out between them. All right, so this is target, get purchased. This is where we get our purchased ones. We're looping through each of them. Threads used. We increment and we're going through. So I'm just going to copy this. Bring that up here because I'm going to need something kind of similar. So I'm going to loop through each of the servers. And I want to calculate my total RAM. So var total usable free RAM equals 0. We have no free RAM available. We're going to start with, I don't need to worry about our threads. We're going to add home to our purchase servers. Our server names. Did I need this I for anything? No. It's only used to get the server name. So forget this. I need to change this to a for of server name of our server names. Fine, I will change you to actually be that. So now I don't need that or this for, so I can delete the bottom so that way it connects down below. No squigglies. So yes, I did not need that I. There we go. Okay. Cleaning up code as you go. It's a good thing. Makes life easier, better, stronger, easier to work with later. All that kind of stuff. All right. Get our server. Get the free RAM of that. Now we want the floor of that. We want our max threads available for that, right? So we had our free RAM. I need to change that into the total. So it's getting free RAM. Maybe I want to not actually get the total usable free RAM. Maybe I want to actually change this to total usable threads. So RAM, because I've done this max script RAM, and I use that based on how much free RAM it has available to get the amount of threads. And when I come up here, I need to calculate the number of threads used for that based on the free RAM. So instead of returning free RAM and doing the same calculation again, I think what I'm going to do is actually just return the number of total threads, and that will allow for what I need. So yeah, I think that makes sense. So this is the threads available. So let's change you to total usable threads. Oh, sorry, I'm getting tired. All right, so we got our total usable threads. We're going to add, so plus equals. We're gonna, and in case you haven't used plus equals, I mean, hopefully you have by now, but basically it's the same as doing, for example, x equals x plus y, right? This would be the same as, you know, x plus equals y. These two would be the same, right? Same, they're the same. So threads usable, and we already have it 0. Why are you declare best values never read? Okay. I was thinking it was gray because I wasn't using it and I mistyped it or something. So, all right. So threads available. We're not subtracting. We're not changing. We're not copying scripts. Not doing threads. Okay. We're just getting the total number of usable threads. All right. So we got here. I'm going to do home. I don't need that. Push turns a number. I can't do that. If push had returned the array, then I could have done that, but it doesn't. It returns a number, so this would have been a number, which is not what we want. We need the array. So, okay. So server, get its free RAM available on it. We then take the max RAM to get the total usable. We have the total usable. Go over each of them. Then we return the total usable threads. All right, so now we need to change this. Rename symbol from right click, get total usable threads. All right. Of our threads available equals this, ns. How much free threads we have? Okay. So that handles the calculation of the number of total threads. So now we need to calculate not just that, but we need to calculate the amount of individual hack weekend grow threads, right? Because it might be 1 thread for hack, 30 for weekend, and 20 for grow, right? So we gotta calculate that piece there, right? So now that's where the fun begins. All right, so we have 2 different pieces that we've got going on here, right? So we need to calculate. So let me get to the grow, right? So here we have our multiplier. So we need to growth analyze based on the multiplier. So what we were doing is we were taking, so there are 2 ways to calculate this. One is using the formulas, right? You can buy formulas from the dark web for, I think it was 4 billion. So, right, so that would be NS formulas, and then you have hacking, right? So that's your grow amount, grow percentage, grow threads, grow time, right? So we can, you've got these are going to be more precise and better, faster, stronger, all that fun stuff, right? So this is, if you have formulas available, that's the way to go. If you're on other bit nodes, such as I've completed, you can actually get to, you know, after other ascensions, you can start with threads, so you don't have to actually buy it. So I have that. So I'm going to try and do it without the formulas first, if it's possible. And then we'll go from there. So I can't use this as it currently is because this is based on money available and money max. So the problem is this assumes that the hack has already ran and the weekend has already ran to get back to minimum, and then we're going to grow afterwards. So I need to do it the other way. I need to plan the hack. So let's go down to the hack first. So threads needed for hack. Basically what I've did is we have our hack analyze to get our percentage. Let's read this again here. Get part of the money stolen with a single thread. So when with 1 thread, it gets a certain percentage. And so then I said, well, that I want to do 75% of the hack, right, of the money available. And so I divided that by percent. Now I'm questioning, is that correct, right? Using a single thread, then you will steal 1%. If you use n threads, then you will steal n times of its total money. Am I even using this right now? Now I've got myself questioning. All right, so that means if you hack food and stuff server using a single thread, you will steal 1% or 0.01 of its money. So we did some algebra here, right? I'm questioning myself, so I got to make sure this is right, because if this is not right, then it doesn't matter what else we do, everything's just not going to work. It's going to be total terribleness. We're definitely going to have to add a lot of log messages to make sure that we can look at this and reason that we're even doing this right, because if they're not firing in the right order, it's not going to matter. All right, so hack analyze gives us a percentage. So it says if we want to steal 1%, if we're using n threads, then you will steal n times. Right. So if we use n times, comment, n times the percent equals, and I wanted that to be 75%. So that means I need to divide by, algebra, move the divide by percent so I can move it to the other side. So we end up with n equals 75%, which is 0.75, divided by percent, which is what we have about. Okay. So that does give us that. It can give us a percentage of a thread. So that's why we have the ceiling, to make sure that we get to an actual integer. So we have a whole number, right? So, okay, that is right. Now the question is, this threads needed is based on 75%. So in theory, these threads needed could blow out our free RAM available. So we would need to actually shrink that 75% down, so that way we can actually do that. So I'm going to need to do some math on the weekends, and so there's actually going to be a lot of math to figure that out. All right, so we can analyze, predict the effect of the weekend, turns a security decrease that would occur if a weekend with this many threads happened. All right, so I need to know. Okay, so let's start writing some more of this down, right? So I need space to think and write and do things, right? So what we need is the weekend analyze returns the security decrease that would occur if the weekend with this many threads. So this is determining how many thread things are needed, right? So the security increase, that we're going to need for that we can analyze is based on the grow security plus the hack security, right? So when we grow, so the point of before, right, when we were wanting to do our thing here, right? So the weekend goes first, which means that, I'm sorry if I'm repeating things, I have to like talk myself through this out loud to myself so that way I can help reason about this. They call it kind of the rubby duck programming or debugging, or rubber duck deprogramming, I think it is, debugging. But basically, by talking it out loud, you can kind of step yourself through things so you can figure it out, right? So my grow and hack, these which are finished before, right? And then you're going to weaken everything, right? So this is going to add security. This is going to add security. This needs to take all that security away, so we're back down at 0, so we can immediately do this again. So I need to get the security increase on that. So if I increase grow, I have to increase, if I increase the amount of grow threads, I have to increase the amount of weaken threads. If I increase the amount of threads for security, that means more money is disappearing. So I need to add more grow, which means that since both of these have increased, I need to increase the amount of weaken, right? And it's not a set thing, each one of these, right? So I've got unknowns, these three unknowns, and I can figure out, so I need to just pick, for instance, like here, I was just picking 75, right? So I need to basically create a function that is going to return an object that is the security of those, right? So let's do this. So function get thread object. We're just going to call that function. There we go. Get thread object. Yeah, we'll just call it that. All right, so we need the target that we're going to be doing, because that's going to change how much hacking, because we're gonna have analyze based on that, right? So all right, and then I also need to know how many threads are available. So threads available. All right, so the easiest way, without doing tons and tons of math that I don't really want to try and figure out at the moment, is we're going to kind of brute force this. And so what I'm going to do is, I think, since this gives percent right per thread, for single thread, right? So this is what one thread does. So this percent gives there. So what I'm thinking in my head is, actually, okay, I need to stop. Let's go back to our pseudocode, write our algorithm, and figure it out, right? So I want to get the percent for a single thread, and then get the threads needed for a single hack thread, get the threads needed, get the grow threads needed for a single hack thread. And then get the weekend threads needed for grow plus hack threads. So what I'm thinking is that we add one, right? So we start off with one thread, calculate how many grow threads we need, and then based on the security change of one thread plus X threads will give me Y threads for the weekend. We'll say, well, maybe I'll just use, so we have one thread plus G for grow equals W for weekend, right? So we're getting some more lovely algebra, right? So we have weekend threads is going to have to equal the grow security plus hack security. Yeah, so I have that already done there. All right, so what we'll do is we'll calculate that out. And then if that is still less than the threads available, then we will increment the hack of hack, right? So we'll increment the hack from one thread to two threads and then calculate how many grow threads are needed and then calculate how many weekend threads. And if this is still less than the threads, then we will replace the first calculations with the second set, and we'll keep going, incrementing and increasing until eventually we get to where we bust and we blow out the threads available. At that point, we can say, okay, the one previous is what we need, and that's what we can return. So that's going to be, and that's basically a brute force algorithm, right? I'm going to try each one until I get it right. And so this doesn't involve nearly as much math. It doesn't go and it makes things simple, easier to figure out. The disadvantage to that is it takes longer to figure out, right? So if our threads are 1, I gotta get it on the second try, right? Because number 2 is going to find out it goes bust, and okay, it's the first one. But if we ended up with some super large thing to where, it's the 1 billionth try, because it ends up being 1 billion threads, right? Then that means I have to go and loop through 1,000,000,001 times. So it's going to take a little bit longer, right? That's still linear time. That's I'm not going to get into big O notation. That's a little bit more of an advanced thing, but you can look up big O, right? You'll see it like big O of N. You'll see it like that, but big O notation. You can Google it, but basically it's used to get a general calculation of how long things take before you get an answer, kind of thing. So, yeah. So that's what we're going to do. That's what we're going to try and get, right? So hack analyze gives me the percent for a single thread. Okay, so we have the percent for a single thread. So now we need to var hack threads equals 1. Var grow threads equals let's go -1 to say I haven't figured it out yet. And weekend threads equals -1, right? So those are ones we got to calculate. We're going to start with the first one here. So, and then we want a var. So we have threads available. We have threads used equals, and we'll just say 0, 1. Use -1. Yeah, I'll just put it to 1 because our hack threads up there is 1. So just giving a default. I just don't want 0 in case we don't change it, then we end up, I don't know. Why are you a different color? Weird. Okay. So while threads used is less than threads available, right? So this is that looping piece to say, while my threads are less than, the threads that I'm using is less than what's available, we're going to keep trying the next one until we get bust, right? So until it's more than, we're going to keep looking for it, right? So let's say var previous threads equals this object, right? And this object is going to be hack, which is going to be our hack threads. Maybe I don't want those to be 1. Well, you know what? Let's just put this in here and maybe I end up changing it. Grow threads. Weekend. We're just going to do that. Okay. When we're done, we're going to return the previous threads. Why is my formatting not being okay? Whatever. All right, so got the threads. This is going to be a longer video. All right. So all the threads. Let's just write it, and this is still not making me happy, but I'm nervous about potentially accidentally returning -1 and blowing things up. So, okay. So while the threads are available, we need to increment by 1 and try it. So actually, I need to go 0. So hack threads ++. So we're going to increment by 1. I'm going to add 1 to that. So then I need to calculate the number of threads needed based on money change with money change of hack threads. Calculate the number of weekend threads, or not grow threads. And then I need to calculate the security change of hack. Calculate the security change of grow. Then add the security changes together. Then we need to calculate number of weekend threads based on security, total security change to get total, calculate number of weekend threads. Add okay, I'm just going to do this and then we'll say, right? So add, we can grow. Let's make sure we keep the same order. Not that I don't know if it matters, but and we can threads to get threads used if threads used is less than equal to the threads available, then create a new previous threads object. Yeah, just like that. Yeah, so these actually don't need to be out. I guess I don't need these. Or they can be up here. Format. There we go. So previous threads, which means I don't need this. We're going to say at minimum, we can try and do these, right? That's going to be our minimum, which is not awesome. It's not going to get us exactly what we need, but this will at least function, and but I think we should be fine. So except for hack threads, that does need to be out. I lied because we're plussing it. These do not. So got our calculate, grow threads, our weekend, which is down here, and threads used is going to be down here. And so I can do that one now. Hack threads plus grow threads plus weekend threads. If threads used is less than or equal to threads available, then previous threads equals, actually, let's just do it this way. Dot hack equals hack threads previous dot grow equals grow threads, row threads, there we go. Weekend equals weekend threads. So that takes care of this piece. That's done, that's done, that's done. So now I've got these pieces left to do. Cool. So delete that, delete that, delete that, those. Okay. All right, now comes the hard part. Calculate the number of grow. So the way that was done was based on the money pieces here. So let's just steal that whole thing. Function. We want calculate number of growth threads needed. So we need that. We need the server name. I need the amount of this. So actually I can just move that up into here. And then I need to know how many threads. So hack threads. Hack thread count. So that way makes it easier for me to remember later. Probably do that down below, but whatever. Okay, so we get our percentage for a single thread. So that will mean, right, how much percentage, how many threads. So if I do var percentage equals percent for a single thread times the number of threads, so hack threads count, give me the percentage. So we're going to assume that I have max money, which means I need to up here to do, make sure we have max money, and then to do wait, security money right here. Yep. So we got to get to minimum security, then we got to get to max, and then we got to make it back down to minimum security again. Okay. I missed that piece. Okay. So come back here. Right up here. So we get the percentage. So then what we were doing was multipliers. We had money available, some money percentage to get the multiplier to get that, right? So this percentage is used to get what the money available is. So I need to take max money. Let's switch you. So max money is going to make available money actually be money max times the percentage. Because if it's 0.75 that we had before, we need to multiply that the money max to get us one that is less than. Is that correct? So single thread gave me 1%. So if I take 1% of, 10, 1% of 100 is 1. Yeah, so use 100. It's 1. Money available is 1. No, I'm taking 1 away. So I'm actually need to do the money max minus money max times percentage. If my money max available is 100, I take 1% away. That leaves me with 99 that is available. Divide that by money max, which is going to give me the money percentage, which 100 divided by 99 would give me 1%. Or sorry, money max. 99 divided by 100 is going to give me 1%, which is what I had up here for this percentage. So this percentage is the same as money percent. So this is giving me money percent. So that's this piece here, which means I no longer need the money max or this money percentage. Is that correct? Percentage, money percent. Is this percentage? Why would I take percentage? So 1% times 100 give me 1. 100 divided by 1. It's multiplied as 100. Okay. Okay, so I found that when I take too much money away, multiplier would be infinity. And so I just did this check to say, hey, if it's infinity or not finite, meaning that it is not infinity, infinite, finite is the, yeah. So I just said, you know, screw it. I'm at 0%. I'm at zero money basically. And so just crank it up there. That's kind of why I did that. So I was running out of money. Okay. So using this multiplier, we can grow. This will give us the number of threads needed. And that is what we want to return. Threads needed. I know I could just do return here, but I like having that to help remind me when I look later that I'm getting threads needed here. So yeah, pretty sure I don't need that. So I'm going to leave it commented Ed, just in the off chance I did this part right, but I think I walked myself through to being correct. So grow threads equals that, ns, target name, and hack threads. Okay. Now we have hack threads and grow threads. So now we need to calculate the security change. NS grow. I don't have the NS. Grow, analyze security. Yeah, I think that's what we need. Calculate the security increase for a number of grow threads. All right. Threads that'll be used, the host name of the target server, if provides security increase, is limited by the number of threads needed to reach max money. Host name of the target server, if provided security increase, is limited by the number of threads needed to reach max money. So in theory, I'm hacking, and when I do my grow threads, I should be getting it back to maximum. That way, if I calculate too many grow threads, that would at least let me reduce the amount of weekend. So I guess that's fine. Let's do it. So grow threads, target name, number of cores. I don't know what the cores are because I don't know where it's going to be running. So leave that off. What does... I believe when you first start, you have 0 cores. So let's just put 1 in there just because I'm nervous on what the default is. So I'm just going to put 1. It's probably 1, but I'm going to do it anyways. All right. So this calculates the security increase. This number is the security increase, not of the hack. That's the grow. Var increase equals hack analyze security. Same thing. Hack threads. Target 1. Security increase plus equals. You want to keep these together and then keep these together. Now, we'll do it this way. So that's threads, security, security to get total. That's added there. Calculate the weekend threads. And yes, we can analyze. Threads will be used to perfect. That's not what I want. That's all we got. All right, so I'm going to use, I believe I have calculate number of grow. No, I need, so I no longer need you. Let's clean this up some. Get weekend threads needed. Let's modify this. This is used up above, so I need to create a new one, and then we can figure that out. So if I have the weekend, I can do security increase here, right? So security, yes, just this one, security difference. Right, so I don't need that. Same kind of thing where we did a brute force, right? So this comes down here, and S, and security increase. There we go. You've now brute forced our way. threads are not here. We won't set these. We'll come back out. This will be false. And so it'll not be false because we are setting up there. So var threads. I copied it so I could paste it. What am I doing? 3. Because that's the 3 here, right? Hacking threads. Just start at 1, so that way we get up to, I guess I don't really need, yeah. Zero. Cool. Get thread object. That was a lot for that. Threads available. Calculate the number of threads. So get thread object, ns, target, and threads available. Threads object, because I am terrible at naming and I can't think of a good name. Okay. Okay. All right. Okay. Calculate the delays. Run the weekend. Oof. All right, so we have the threads. We now need to calculate all the things. Okay. Let's see if I can power through this. What do I got? Yeah, another 20 minutes before I make this a total, well, not quite a total 2 hour. I guess I wasn't always started right away. So, it's getting close to my bedtime. Okay, so threads. How do we calculate? So ns grow, get grow time, target, var grow time. Let's go back to the way we're doing it. Hack grow things, right? So hack time equals, let's add it equals. ns get hack time. I think this takes into account the cores. Yeah, because this is not the formulas version, it's not as accurate. So var weekend, let's get weekend time. All right, so those are the times it takes. In theory, weekend is longer than grow, which is longer than hack. So now we need to actually calculate the delay based on those. So I want, as we saw here, the hack to go first, and then the grow, and then the weekend. So I need to I'm going to put a second gap, a 1 second gap between each of them. Or no, maybe I'll do 5 seconds. Well, 1 second. 5 seconds. Let's go. Let's do it this way. const time between scripts, and we'll say 5 seconds for now. It's variable, so we can change it. All right, so I want hack to go, then 5 seconds later, or sorry, hack to finish, then 5 seconds later, grow finish, and then we can finish 5 seconds after that. Okay, so using that, if we start weaken now, how long do we have to wait before grow needs to fire? So if we take weaken, we don't have to calculate weaken. Weaken is 0. That's starting right away, right? So calculate the day before. Okay, so let's calculate grow first. Hack needs to go. Oh, my head. Okay. Let's just do. No, I need to calculate. Okay, come on, mind. Let's work here. I need to calculate. Calculate the delay before starting the hack. Okay. So we have weaken, then 5 seconds, then grow, then 5 seconds for hack. So we have the time between plus time between. So for hack delay equals, so we want to finish 10 seconds prior to weaken. So I need to know hack time plus those, right? So I need, okay, so if weaken takes a minute, hack takes 10 seconds, I need to have it start the 10 seconds for hack time plus the 5 and the 5 gives me 20 seconds. So I need to start it 20 seconds from the end, right? So if weaken takes a minute, then the time I need to start is actually 40 seconds after, right? So that's going to be a minute minus the 20 seconds to give me 40. Okay, so I have weaken time minus this group here. Gives me my hack delay. So that's that piece. And then for this delay, we have the var grow delay equals the weaken time, because it's the basis for everything. We want this to start 5 minutes or 5 seconds, or the time between, right? So grow time plus the time between scripts. So a minute, this is 40 seconds, 45. So a minute minus the 45 is 15. So 50 minutes there. Okay. So now we need to run. Do I have all running scripts? I don't need this section. Run grow scripts. I don't need that because that's the one I copied for the other one. Run the weaken scripts. I use that for the all. Run hacking scripts. This is, oh, there's the script. I need to go back and grow scripts. I need this guy. Run scripts. Run scripts. The target server name. Threads are needed. This is what distributes across the things. Okay, so that's good. Go back. Right, grow scripts. Threads needed. This is going to be the threads object dot grow. So we can, so this is going to be weak script path. We can okay. Await the grow, or hold on, not await. What am I doing? Sleep. The grow delay. Then we're gonna run. Oh shoot! So our hack delay is based off of crap. I need to make it based off the grow, I think. Crappity crap. Okay. Oh crap. Okay, let's change grow to be here. Okay. This okay. Crap. Okay, so now we come down here. So we need to calculate and wait and all that fun stuff. Okay. Okay, so I'm delayed. Crap. Okay, how do I figure this out? So we've ran the weekend. We know that we have to start the time to get the start of the grow. And we're waiting here. This would work if I was starting it at the same time as the other one, but I'm not. All right, so this is why it's best to add that, because then I could pass that in as an argument here, and it would run in the correct time. It would have the wait within the script, and then it would go. Okay, so that's a thing that we need to change. So let's go ahead and finish this here. And so this will be the hack. All right. Wait for all 3 to finish. All right, so to do move the sleep into the script and pass the sleep delay as argument. Then here would be await as sleep of the weekend time. And we'll add a second just to give it a little extra. Okay. So that's that. Cool. And then while true. And format. Cool. There we go. So the only things we got to do is open up the other things and pass that in and modify our run scripts. So that way when we exec, thread options, let's see, scripts, server name, threads available, number or run options, and then our target server name. And we would have up here delay, pass in delay, and we need to have delay things here. What terminal cd scripts, what do we got, HWGs and all that, cd HWGs, single loop, can I do help, I think CP for copy. Yes, CP copy. Okay. So I should be able to CP single dot hack to be delay hack.js. Yes, went to the right place. Okay, so we can do that. We're going to do grow. No, it's not going to autocomplete. I think it's grow. Grow. We can cool. So now cd delay. So nano grow. So we need to await ns.sleep ns.args 1. Grow will have 1, yes. Okay. Copy that. Come in here. I guess I need to do weekend, but it's there. Cool. All right, so that's there. Okay, so now we come up here, change to delay. So the weekend delay is going to be 0. Grow is going to be the grow delay. Hack delay. Don't need you now. Okay. And then I need to come back here and nano weekend. Oh, I guess I don't have to. It doesn't change. Okay, that's fine. I don't have to do a sleep. Okay. Food and stuff. Syntax error. Oh, great. Declared. Get 3 threads needed. Okay. 224. 224. Get 3 consonants needed. I don't want to do 2. Get weekend threads needed. For batch. Terrible name. Okay. Get the Drickens for batch. There we go. 13 gigs. Okay. I think I can run it. Run batch hacker. For that, let's come up here and ns.clearlog and ns.tail, because I don't want to deal with that. No, come back. Run batch hacker. Crashed. Kaboom. Target server not defined. Of course it's not. Line 73. Okay. 77. Target name. That's what I get from mixing and matching. Args is not an array of script args. Crash 2 args, not okay. Stack line 168 run scripts 168. 68. Do I need to? The args have to be of script args array. I don't know what a script args array is. Let's see if I can. I think I can just do an array, right? So let's just try that. Var args equals an array that has target server name and delay. Let's see if that worked. No. So I need to figure out what scriptR's object is. So I believe, let's just do nanos test. All right, so let's just comment that out. Print, not print, ms print, ns.args. Run test. Fine. Run test, blah and blah, and let's give a different one at least. And that. It's an array that, okay. Ugh. Okay, you're killing me. That's what I did. And this args is a script args. Isn't that what I just, I basically did that. I said args, array, args, then it must be filled in with I did that, right? So right now I get that. So it's not an array of script args. Okay, I'm gonna have to figure that out because I don't know why it's being dumb. Trying to do some Google searches and I don't know. Oh boy. So, all right. Found this script arg, which a type, which is a string number of Boolean, right? So 173 didn't look at his args. Do I just might have to end it here, or maybe I'll trim the video. Okay. Args not an array of script args. I have an array. Delay. Script args, a string number, Boolean. I'm an array. Thread options or run args. That's what threads available is. String, yep. So args. An array of, do I need an array that is do I need a double array? I think it might be a double array. Array is still not a... Let's move it up here. Script args. Script args. BitBurner. Let's do Google search for BitBurner exact arguments. Exact functions with multiple arguments fails. Okay, here we go. Maybe this will get it. Does it use target name delay? That's the way I had it originally. Right, so based on this guy, I'm doing it right. Right, so 1, 2, 3, 4, 5. Right, so 1, 2, 3, 4. I mean, oh, this is net script function. I want just 2. Okay, maybe not. All right, I'll keep looking. Oh. All right, keep looking. So if I go args and unpack, okay, so let's just change this to radium spill. Arguments. Does that work? Cool. So that is okay. So this is how we do it. We need to, I renamed it so that way we wouldn't get confused by the naming of it, you know, since it has args here. I just didn't want to confuse people. So arguments, I have to unpack it in an array to go. The spread operator. All right. I should know that this is an actual JavaScript thing, but I've never really had to use that. So, yeah, just to share what I had searched for. Let's go to Chrome. BitBurner exec arguments. That's just what I searched for. And I looked at the Steam community one, and it had here talking about the spread operator. And so that's how I figured it out. So, woo. All right. Now we can get back to what we were doing. All right, let's come back here to BitBurner. All right, so could not calculate RAM usage for BitBurner on home. Well, that's not helpful. So I need to add in here some log statements. ns log print let's come down here. Hack threads is going to be hack threads grow threads total security increase. Oh. Again, threads and threads used. Up here, let's do stop print, come on, threads available. Oh, duh, I have a so dumb. Binding arguments in strict mode 168. Oh, that was so dumb. 168. Fine. Blah. Oh, I thought I fixed it. Okay, maybe I didn't. Okay, someone else is having the same issue in that same script args. It's a server name. Oh, you know what? Because I didn't. Okay, hacks not running the weekend. That's why. Because it's being undefined. Undefined. So yeah, if we look at the script args thing again, right? Script args is a string, an integer, or a Boolean. Since I did not put, there were some of these that were missing, it was getting undefined. Undefined was being passed in, and that's what it was freaking out about. So if I go, and I think I got cannot weaken because I don't have access. Yes, okay. So that was the issue, is that I was undefined. So I should do here on the delay, delayed run scripts. There we go. Come in here. Var script delay equals delay if not script delay, then script delay equals 0, right? So if I forget to put a script delay, yeah, no, I'm not. Okay, wait there. All right, so now if I come up here to run weekend scripts and move that back to 0, now if I come up and run this, oh, I gotta change script delay to delay here. There we go. Okay, now run it. Yeah, now it worked. Okay, yeah, it was exactly that. It was because it was undefined, and undefined's not one of the things allowed. Okay, so okay, so let's stop this. I've got run scripts util root the world. So I should be good to run. Yep, it's sleepity. Okay. So active scripts. I did not use everything we might. So scripts, connect to food and stuff. We can since I'm here, might as well grow some. Of course, now I've really thrown it off. Oh, it'll work. All right, I'm gonna have to do lots of editing on this video to get it down to decent sizes. And it is past my bedtime. All right, come on. Yeah, I don't have enough. Did it jump? All right, I have some money, so let's go active. I need city. Not quite enough for more, but from purchase servers. There we go. Purchase some servers, that should help. Yeah, there we go. Yeah, 4 threads, 4 threads, 4 threads, 4 threads, 9, 9, 9. That'll be better. So I wish I would have thought of this earlier, because, well, actually, I can change to noodles and stuff. Oh. I said noodles and stuff, didn't I? There we go. Oh, I have. What am I thinking? I've got this other one. Oh, no, I don't have the other script running for. Okay, cool. So it is just the batch guy. Okay. So connect to noodles. We can grow. Get that tapped out. Okay. Zero threads to get to weekend. Oh no. Okay. So because it did that second one and there's a bug that it still slept for because of the way the other one worked. That's crummy. Okay. So just gotta wait a little bit. All right, come on. I want to get to bed. Nope, it's stuck. Okay. Well, the current security is greater than minimum security. Getting target noodles to minimum security before batch. Get 0, 0. Oh, bother. Something dumb. I need this inside, otherwise it will never get new value. Except I need it on the outside, or the while will not work. So I need to also put these inside. There we go. Multiplier must be between finite and greater than 1. It is 99. Okay, so I didn't do that part right. 226. 226. Multiplier itself needs to be. Okay, let's undo these. I thought percentage 20%. Let's just see if I messed that up. And negative. Yeah, okay, so I was probably right. Okay, it was telling me that helps if I save. It was 0.99. So I need to ceiling on the multiplier. No, I'm going to do if the multiplier is less than 1, then set the multiplier equal to 1. Let's see if that does it. Oh boy, I had all sorts of errors. 44. Let's go target, target, target. So hack with 10 threads, 10, that's not the total threads. Okay, so I need to NS disable logs. So SCP, don't need SCP. Okay. So it had some weakness there. Let's get that to wait. I think I've got timing off. 8 threads of weaken. Yeah, okay, let's stop this. Weaken is 8 threads. Wait, hold on. There it is. Oh, okay, so hack threads is that. Grow threads is that. Total security increased went to that, so it required that to get to min. So it was 8 total threads used. That's not right. So a hack. Okay, so I messed up in my log statement probably. Yep. Grow. So it still says 8 threads to get to min. Grow thread 0. I can't have that be 0. That's supposed to be 1. Calculate number of threads needed. Oh. All right, ns.print percentage let's look at, come on, there we go. If grow threads needed for a given multiplicative factor. So do I need to multiply the percentage by 100 to get the multiplier? Because that would be 99, because before I think it was 0.99, so that would make it 99 some odd, right? So let's go back. Saved. Ooh, monitor, that'd be good to look at. So you can see, watch. And we need to just I need some breaks between those so I can better follow. That's also an issue. Yeah, there's just going to have to be a lot of debugging and things. This is not going to be all that great. So I will have to do this another time, I think. All right, stop. To look at, I can't. So it's increasing the threads. Okay, so I messed that up. Another problem is that or no, did I mess that up? Maybe it's not a mess up. Yeah, you can see our threads are going up. The percentage goes up, but our total increase is not going up, which makes me feel like I've screwed something up, right? Because grow threads are not changing. It's almost like I've got too many hack threads. Right, so yeah, we'll have to figure it out some more. All right, I'm gonna stop here because I gotta get to bed, and I'll probably do a part 2 and try and pick up exactly where I left off here. I'm gonna have to do a bunch of editing and things, and we'll kind of go from there. All right, take care, guys.